going to try and capture the Orion Nebula. It's been cloudy for weeks and it's my first capture of 2026. This is my first time doing the Seestar Mosaic mode and processing it after the fact. I used all free tools. I figure the tools to process shouldn't cost more than the device itself. So for the Seestar, I'm going to try and always process using free tools that are available and see what kind of results I can get. So if you have any recommendations or any ideas on things that I can do better, please let me know. I'm always trying to learn and improve my skills. So these are the images that came from the Seestar. You can see the subs here, a list of them that saved for each shot that will be stacked. And then here is what the Seestar put together. And you can see some slight discoloration here. I think maybe, with lights, or I think this target went behind a tree at some point. So these might be also some branches. And we can also see some seams here. And I want to try and restack that and get rid of these seams so that we can have a more uniform image. First thing that I'm going to do is go through these subframes and see what can be rejected and see kind of where we land with better source information. So I'm going to put a rejected, and then I will be running a script that is going to look for the leftover subs in a lights folder. So I'm going to create those. And the way I like to review those subframes is through a program called SETI Astro Suite. It's got a ton of great tools, and one of the ones that I really like is this blink comparator. So we're going to go ahead and open that up, and this will go through a folder that you can give it so that you can review all the lights and see if there are any issues. So it's loading up the images now, and then once it finishes with that, we'll see a list, and we can kind of cycle through them and see what looks good and what doesn't. All right, now all of the lights are loaded. I'm actually going to make this a little bit bigger. As I click on the first one, I can see it looks good. As I go down through here, I can see where it moved to make a mosaic. So in the mosaic mode for Seestar, it doesn't do it in panels. It kind of rotates around every few frames. So I'm seeing that, and they look good. Just going down through there, seeing if I see anything. I can hit play here and it'll cycle through them. Some lights going across there. Everything looks good here. Let me actually pause this and start from the bottom. Here I can see definitely some issues. Kind of go up through that. To me, that looks like when Orion went behind some trees, and these are the branches, which obviously that's going to cause some issues with stacking. So let's see if I can get to where that started. So it looks like there's none here. So I'm going to go down through and try and see where it starts. I can see it right here, and I think there's some right here. So I think once it starts in this cycle is where there's some branches. So what I can do is select all the ones that have the branches, and you can move all of the selected items. I don't like to delete anything until I'm sure. So I'm going to just move all of those into the rejected folder. That's 130 frames that were moved into the rejected folder. So that should make a huge difference in the quality of the stack. The other thing that's really cool about this tool is it can take a look at some of the metrics around your subframe. So when I click on show metrics, it computes all of the information, and it'll pull up 4 graphs, and those graphs full width half max. I believe that's what that is. The background, the star count. So if they're like clouds, it'll be less stars, eccentricity. So I'm going to take a look at this, and what I can do is as I lower this kind of threshold, it will select frames that I can reject. And so like these frames may not be good frames due to the way the stars, there might be movement in the stars may not be good. So what I tend to do is just look for groupings where things are all the same and try and reduce some of the frames so that only the strongest background, the roundest stars, good sky, those are all the ones that I'm going to try and target. So as I kind of go down there, and those red ones end up being flagged. So these are ones in the stack here that are flagged. And if I right click on and I say move all flagged items, I can move all those to the rejected as well. So that's 51 more frames. So down to 366 images, but those should be the best ones, and those are going to be the ones that I use for my stacking process. So the script that I'm going to run in Serial to stack those are going to be looking for those mosaics in the subs in the lights folder. So I'm going to come back into this folder that had the original files that we removed. It's the 366 that were left. I'm going to copy that to the lights folder. And so that's where the script's going to look and process them so that they can stack together. So in Serial, there's an amazing script by Naztronomy called Smart Telescope P. It's a Python script. You can get it by going to Get Scripts, and if you type in Astronomy, just select these two and it'll click apply, it'll load the scripts. But here, if we go to pre-processing Smart Telescope, it brings up this dialog box, and I'm using the Seestar S50. It's already calibrated, so I'm going to just do cleanup files and use compression. I only have 366 files, so that max isn't an issue, but I do want it to do the background extraction. I want it to do 2x drizzle, and I'm going to enable filters and stacking. For stacking, I found that feather is what eliminates those seams, and it's really an amazing part of the script. So I like to increase the feather amount to 30 just so there's more overlap and reduces the seams. So then for post-processing, I just do the color calibration. The target was using a narrowband filter, and so once those settings are done, I'm just going to go ahead and click run, and we'll see it process the image. You can see here that it's going through and running all of these processes through the script. It's really quite amazing, and really grateful that he put this out there for us to be able to use with the Seestars and all these smart telescopes that do so many individual frames, and we need to calibrate them, and especially for the mosaics, I found that this is really great. All right, so the script is done, and let's check it out and see how it looks by putting it into an auto stretch, and you can see the difference immediately. Let me pull up the original Seestar image. You can do a side by side here, and you can see the difference in the hard line seams here are gone. Some of the other processing will handle the background and normalize that. So I think this is a great start, and much better than what we had. And then we'll go ahead and get started processing it. Okay, the next step is going to be processing, and I am definitely just still learning this. So I'll go through what I am doing, and then if you have any recommendations, please let me know. But the first thing I'm going to do is crop this image to get rid of these outside areas that have issues and increase the area that we're working with. So I'm going to right click on the image after I make a selection and click crop. So there's still some issues here. I think that's pretty common in the Seestar, but it's much better kind of initial area to work with. And then after that, since we've cropped it, I'm going to go ahead and do an image solver process. I think that's under the astrometry and image plate solver. So basically I just keep all the settings default and click OK, and we'll see that it goes through and solves the image. All right, so the first thing to do to the actual image is I'm going to do a background extraction, and hopefully that will improve the way the background looks. And so the settings that I'm going to be using is, instead of subtraction, division, and I want to do kind of more smoothing of 0.28, and then I'm going to do about 10 samples per line. These are just settings that I found have worked for me, and a grid tolerance of 1.32. I think that keeps good and uniform. And so I'm going to generate the points, and see that by making the samples per line lower and the grid tolerance, I'm right-clicking on all these points near where the nebula are. It's going to eliminate the background extractions in those areas and then focus it on outside of the nebula and the target. So I'm right-clicking on all these near the nebula so it doesn't remove any part of that. You can see that it's really focused on outsides of the image. So I'm going to go ahead and, after those are all deselected, compute background, and you can see that it went into effect. So now we have this background image that we can work for. And I'm going to rerun. I selected the color calibration, but I'm going to rerun it now that we've done some things to the image. Basically selecting Seestar S50, and it was using the light pollution filter. So let it redo the color calibration. And here are the summaries for the white balance. All right, so this is what it looks now. And two scripts that I like to run to sharpen and denoise the image. I'm going to go to Python. Well, so let's go to Get Scripts, and these cosmic clarity scripts, I went ahead and selected all of those. I used the sharpen and the denoise one, and then also the Graxpert AI script, and I selected that. So once you have that, you can go into processing, and the first thing I'm going to do is sharpen the image. I do both. Cosmic Clarity does not use my GPU. Select that or I'll get an error. But I keep everything default, and I just apply that. We'll see that will take the sharpening settings for the image and see what it looks like after that. All right, now that process is done, we'll go ahead and run a denoise. And to do that, I like to use the Graxpert AI denoising. I like to set that strength to 0.3. We'll go ahead and apply that. This is all being done while the image is in linear mode. We haven't stretched it yet. We'll be doing that next, and hopefully get a good result. All right, now that that's done, we'll go ahead and do a stretch. I'm still learning a lot about stretching. What I end up using is the Statistical Stretch by SETI Astro, and I like it because it has a lot of configurations, but as I'm still learning, I think getting something that's more automated is helpful. So I like to just kind of preview what it's going to look like. I like a little bit on this was the original, so kind of the original, you can see. And then as I lower the target median and we do a preview again, you can see it gets a little darker, which I like. I select no black clipping because I feel like it really affects kind of the output of the image. I like the way that looks. I do a link stretch to ensure that all the channels are linked, and then a normalize. I don't know. I just select that because I think that, you know, ends up looking good, and just kind of continue to do previews. The enable HDR compress is something new, and I like that because you can impact how blown out the core is here. And I actually reduce this a little bit, so I go from 0.15 to 0.12, and I'll just do another preview, and you should see here it'd be a little less blown out there. And so this is the original. Oh, and then this is the stretch. So I'm going to go ahead and click apply, and now the image is stretched, and we'll go ahead and move this back to linear mode. And so here's the image right now. I'm not going to remove the stars. I think, you know, for this image, I just wanted to get a mosaic, you know, processed. But my next step that after the stretch is I like to remove the green noise, and I just apply the default settings. And, it changes the background a little bit. And then the background neutralization, under color calibration, for the background neutralization, kind of go in and select an area of the background that has no stars. So select that. I'll use current selection, and then I'll do background neutralization. You can kind of see the effect it has there. And then finally, I'm going to run another Graxpert after the processing, or after the stacking. I'm going to run another Graxpert Denoise. And again, I'm going to go down to 0.30 and apply that. I still see some of the bad imaging here from the Seestar, but in the end, this will be a better image than what came out of the device itself, and we can always work to improve it in future images. So this is denoised after the stretch, and I'm going ahead and do a curves transformation and try and just lower the black point a bit on the image. Kind of create that standard S curve. The image. So I like the way that looks. So this is the image that like it ended up, and so I'm going to go ahead and save a unique file, and that's going to allow me to open it up in Gimp for kind of a final curves processing. So I'm going to go ahead and save the fits file as well. Go ahead and save that. Then we can go ahead and open up Gimp. So I will just open this file up. What I like to do is just duplicate a layer to apply the curves transformation to that layer, and it should so kind of another S curve, very subtle S curve there. And I am going to go ahead and select this and maybe just redo the crop here. Yeah, just continue to kind of crop it to what I want to see. This looks good. So in Gimp, if you want to kind of save it as a PNG, you gotta save it as, export it. So I'll do kind of a version 2, and I'll export that as a PNG that I can post if I want to. And I'm done with Gimp. Gimp, I don't really do very much in that with these, but now if we take the original mosaic that came, the JPEG that came out of the image, and we go and take the RStack processed image. So this is all done with the same data. And I think, going through these, using these free tools really can help pull out and make some amazing images with the Seestar. And this was really my first time with mosaic mode, and that script from Naztronomy was really key in being able to get to this endpoint because of the way that it processed and stacked Seestar specifically. So I definitely appreciate that, and I'll go ahead and post this online.